Finally, we get to look at the graphs of the reciprocal functions. Look how funky these things look. So down here, once again, color coordinated, we have our sine graph, and it's in red. And then we have our cosecant graph, which is in green. So if we remember, cosecant is sine flipped. And this is why I teach sine as a hill and a valley. Because look right here. If sine is a hill, when you flip a hill, it becomes a valley. And when sine is a valley, when you flip a valley, it becomes a hill. Now all we have to do is make sure that when we do our graphs, that we pay attention to where the graph is, once again, undefined, which we talked about in the tangent wave. So if I were to look at my sine wave, sine is 0 here, here, and here. And if I wrote 0 as a fraction, it's 0 over 1. But what happens when I flip 0 over 1? I get undefined. And that's why my graph is undefined wherever the sine is 0. I have my asymptotes again. So cosecant has asymptotes at x equals 0, x equals pi, x equals 2 pi, and forever and ever. All right, so if we had to look at the domain and the range, let's see if we can write them out. Well, the domain for sine is every number in the world. It passes through every x value we can see. However, the range, remember, are the y values. And the highest point a sine wave hits is 1. And the lowest point a sine wave hits is -1. So its range can be written as such. But remember to use a y in the middle because you're talking about range. Or you can write it the calculus way, using square brackets to indicate that the lowest point is -1 and the highest point is +1. All right, well, let's do the domain and range for my cosecant wave. So we got to look at the green. Well, I'm going to do the range first because that's kind of easy. The lowest point a cosecant wave hits is, oh, I don't know, man, this goes on. Look, the lowest point, this goes on forever and ever and ever. And the highest point, oh, wow. So how am I going to write that? Well, it's easy to say this way. We're going to write it the calculus way. Negative infinity to -1 union 1 to infinity. Now notice when I did infinity, I used rounded brackets because there is no definite infinity. And then I squared off -1 and +1 because I actually hit -1 and +1. All right, what about my domain? Well, we already talked about my domain. My domain are all reals except, and let's try and use that professional that we talked about with the tangent wave, k pi. Did you notice every time I had a pi, I was undefined? And k is any integer now. No matter what integer I put in front of that, I am going to get undefined. So in other words, my next one, see how this went 0 pi, 1 pi, 2 pi? Guess where my next one is? Right, my next asymptote would be at 3 pi. All right, so let's look at our cosine wave. Our cosine wave is a giant valley. So when we go to flip it, it doesn't turn into a giant hill because we have to look at the parts. Definitely right here is a valley. It's below the x-axis. So when I flip below the x-axis, that valley would turn into a hill. Now up here on the cosine wave, we have half a hill. So half a hill turns into half a valley. Okay, so you get the idea. So once again, when I look at my cosine wave, what's the domain for my cosine? All reals. What's my range for my cosine wave? Much like the sine. It hits a low of -1. It hits a high of +1. Alright, so for my secant domain, well, once again, I look at my domain. I hit all reals except, well, the domain is kind of like that tangent wave from yesterday. There are definitely places where it is undefined. And if I take my dotted line right here, it happens to be the same exact places where the tangent wave is undefined from yesterday. And, well, the tangent wave was undefined here because that's where the cosine hit 0. So it's all reals except k pi over 2. Notice every time it's a pi over 2 where it's undefined. And we learned yesterday where k is an odd integer. So that means, notice this is 1 pi over 2. This is 3 pi over 2, and it's going to be undefined later on at 5 pi over 2. And if you notice too, it goes defined, undefined, defined, undefined, defined, undefined. Its range, well, it's much like the cosecant because it goes incredibly low. We don't know how low it goes. Keeps going. And then it hits -1. Skips, make our union sign, starts again at 1 and goes on to infinity. And once again, being careful with the difference between our square brackets and our round brackets. Our last set of reciprocal functions are our tangent and cotangent. Wow, that looks kind of cool. All right, so our tangent wave, if we remember its domain, all real numbers except k pi over 2, where k is an odd integer. All right, so here's my red tangent wave. It gets really, really close to its asymptote, x equals pi over 2, but never touches it. But notice the cotangent wave does touch it there. And that's again from yesterday. If this is undefined, it's 1 over 0. And when I flip 1 over 0, I get 0 over 1, which is a perfectly legitimate answer. Let's continue with the tangent. Its range, oh, we liked its range. It was easy. It was all reals. All right, now let's look at the cotangent. Well, it's all reals except, well, let's find out where the cotangent is undefined. Cotangent is undefined here at 0, at pi, and again at 2 pi. So that looks like all reals except k pi, and where k is any integer. Doesn't have to be odd, it can be any integer. And its range, well, its range is just like its friend the tangent wave, all reals.